Okay. All right, so we're going to wrap it up today, essentially. But of course, after class today, just keep working, behind the scene, and I may not be here in our class time anymore, but just send me an email if you need me to work with you on anything, okay? And we can do Zoom, or we can schedule to meet in the class here somewhere else. So today, I hope we'll be able to cover the remaining part of the finals that we didn't review last class, and let's try to do that quickly. And then we can talk a little more about logistics and end of semester stuff at the end, right? So let's start upfront by solving questions so that we can save time today. All right, so last class, we were able to do question 1, 2, 3, right? So if you're not here, we have a video already posted, the class video for that. I'm gonna skip question 4 and 5, right? We'll come back to it. Let's do that last. Let's do question 6. Okay, so question 6 covers, so question 6 is a sample question, right? And this sample question is representing what could come from chapter 7, chapter 8, chapter 9, right? So the way it will work is that on the finals, you're going to randomly get one of the questions, right? In chapter 7, I think we did confidence interval. In chapter 8, we did one sample mean hypothesis. And in chapter 9, we did 2 sample mean hypothesis, right? Out of these 3, okay, so one was paired sample and one was dependent sample. Okay, so out of these 3, I think the independent sample mean has the most complicated formula, right? Not complicated, but the formula with more inputs. So we're going to use this example to illustrate that. But on the finals, you could get one of these 3 questions, right? So it will be randomly assigned. Just the way quiz 2 is. So, but there'll be only one question from that section, so that you give it not too extraordinary time, right? So everybody will get one of this type of question, but you could be solving paired t-test, somebody else could be solving independent t-test, somebody else could be solving, confidence interval. So it could just mix up a little bit, but all of them will be of equal difficulty, okay? All right, so we're gonna use this. This is actually one of the examples in quiz 2, but I just altered the number a little bit. So we're just gonna use it to illustrate how to do this. Okay, and so by the way, this is posted here, right, on the assessment tab. Under final exams, you're gonna see final exam review 1 and 2. That is what we are working on right now. Okay. So let's get started quickly. And if you have questions, just reserve it towards the end so that we can cover a lot of grounds today. So we have a scenario as usual. So the scenario said the blood sugar level of 3 randomly selected volunteers were taken before an exercise routine. After that, the blood sugar level of entirely new 3 randomly selected volunteers were also taken after the same exercise routine. So one was taken before, one was taken after, but what is key here is that these are 2 groups of people. And once there are 2 groups of people, you treat them as independent t-tests, right? If they are the same group of people, then you treat them as paired t-tests. So we know here that we're doing independent t-tests because we have entirely 2 different groups of people, one taking it before, the other group taking it after. Okay, so it says here, in the data set handed to you on paper, so I've included the data here. Before means the blood sugar level before, and after means after, of course, after exercise, right? So the question is, does the blood sugar level before and after differ? I mean, is there a difference between these 2 groups of people? And we're asked to assume a normal distribution 1, and we're also asked to take alpha, and I think I should be writing this in words. Let me say significance level. That doesn't confuse us. Significance. Okay, so we assume we are asked to take alpha or significant level as 0.1. Okay, I actually have that statement there. Okay, no problem. So the first question is, what type of test is appropriate for this study? So we've noted that there are two groups of people, and we've noted that we are supposed to be asking the question, does it differ? Right, so that would be independent sample t-test detail, right? So let's fill up these spaces. What type of test is appropriate? We'll say independent sample t-test. And if you like to add reason, that is fine, right? Independent sample t-test. And our reason, of course, is because we have two different populations, two different group of people that we're dealing with. So the second question says, state the null and alternative hypothesis. So these are things that could be picked up easily, right? But you have to be clear with what type of test you're doing, isn't it? So here we know we're doing independent sample t-test, so we know that the null hypothesis. The null hypothesis will be H0 is that the group 1, mean of group 1 is equal to mean of group 2, always, right? The null always uses equality sign. And then the alternative, the question is asking if they differ. So it's not saying greater than or less than. If it were saying greater than, we know it's one tail to the right. If it's less than, we know it's one tail to the left, but it just says, do they differ, right? So we're gonna have H1 here, alternative, as mu1, does mu1 differs from mu2, right? Okay, so that is that. We go to the next one. What is the confidence level of the test? So for some of these numbers, I put in the answer. We're going to be walking through so that you see how we get to those answers. So what is the confidence level? The confidence level is normally in percentage, right? And the hint is here. Confidence level is given as 1 minus alpha always, right? But I want to write in green here that remember, just additional explanation. Remember that alpha could be given as decimal, in which case it's like 0.1, the way we have it here, or it could be given as percentage, right? In which case, if it is 0.1, then that should have been something as 10%, right? So depending on the way alpha is given, that is the way you work on the formula here. I think we have a little thing about that on the quiz. But I was lenient in grading that. So but pay attention to it this time. So if I have alpha given as a number, then I'm using this formula, right? But if I have alpha given as percentage, then I'm using that confidence level is 100 minus alpha, right? So that both of them get you to the same place. So let's see how we do. Okay, so in this question, we are giving alpha as 0.1 as a decimal. So we're using the first ones. So confidence level here is 1 minus 0.1, right? And that gives us 0.9, but your answer is supposed to be reported in percentage. So if you multiply this by 100 to change it to percent, that will give you 90%, right? Okay, but assuming alpha was given to us as 10%, then we would have used confidence level is equal to 100 minus 10, and that will still give us the same 90%. Okay, all right, so you watch out for that. And stop me if there's any question. I'm trying to move fast so that we'll cover a lot of ground today. The next one says, what is the critical value? Okay, so the critical value could be a T critical value, and I will explain that in green here, and then we solve this problem. The critical value could be a T critical value, and critical value is written this way, right? T alpha over 2. That could be my critical value here, or it could be a Z critical value. Which one it is, you know that we use Z whenever we have population standard deviation. So you look out for that word population, right? But if you look at this question, there is no population standard deviation given to us anywhere. We just have a sample data. So because of that, we know we are using T, right? So let me note here that for all sample data, just go ahead and use T alpha over 2, right? Some other textbook will have some other rule like 30, if it's up to 30 or if it's not, but we're not using that here, right? Because in reality, we don't really pay attention to that. So whenever you're giving a sample data, you know your critical value should be a T alpha over 2. But if you're giving population standard deviation, so if that is given to you, right, and then you know you're using Z alpha over 2 for your critical value. Okay. So again, underline this, right? Look out for that to be sure that that is what you're doing. Yeah, so one thing I didn't emphasize in class is that for two-tail, you actually need 2 critical value. But again, I'm not going to be focusing on that. So if you do only 1 critical value, I'll still grade it as correct, right? But for two-tail, you need two critical value. For one tail, you need only 1 critical value. Okay, so but they are worked the same way. It's just the same formula, right? So if you're using T alpha over 2 when you're done, if the result you got was the positive one, which is expected, just produce the negative one as the second answer. The same value, everything, right? But again, I'm not going to be penalizing for that. I'll just let it slide behind. I know that if you have a reason to work on this further after this class, like you're taking another course that will capture that, then probably will be emphasized then. Okay, so I hope this doesn't waste my time today. Okay. We copied it, try to paste it here, see if that will work. Okay, over there. Okay, let's go ahead and solve this very quickly. So from what we've explained, I want to believe we all know now that we are going to use T alpha over 2, right? So you go ahead and get your alpha. So there are 2 stages to this, right? Pay attention that for T alpha over 2, you need to first of all compute what is your alpha over 2, right? And you don't stop there. If you do, you have half of the mark, right? So alpha here is 0.1 divided by 2. So let's write it alpha over 2. This would be equal to 0.05, isn't it? So you've gotten that, but for T distribution, you need your degree of freedom. So degree of freedom is n-1. So we know that df here, okay. This is independent sample t-test, right? So this is another source of mistake. Degree of freedom here, because we're dealing with 2 samples, right, will be sample 1 plus sample 2 minus 2, right? Okay, so over here, we know that sample 1 has 3 values, sample 2 has 3 values, and we're going to subtract 2 from that, and that will be 6 minus 2, which will give us 4. So our DF is 4, right? Okay, so once you've gotten these 2 values, you've got your alpha, you've got your degree of freedom, you can go to the table and pick up your critical value, okay? So we now say our critical value, T alpha over 2, will be equal to, we go to the table, look for the area of 0.05 and look for 1 tail, right? And then look for DF of 4, okay? So I've already opened the table, but you know, we have it here under unit section 2, unit 5, I think. Okay, so yeah, it's somewhere around here. I don't know. Okay, so it's right here under unit 5, resources for unit 5. So you have your normal and table here. But you can print yours if you want to when you're coming for the assessment. So I've opened the, excuse me, open the t-test here. So we're looking for the area of under 1 tail. We are looking for 0.05, and it's right here, right? And even if you think about this as 2 tail, you can also see 0.1 immediately underneath it. So it could go either way, but I want to be consistent with using 1 tail, okay? So you have 1 tail here, and then you're going down this going to degree of freedom of 4, which is right here. So essentially the number you're looking for is this value. We can color it. So we're looking for this value, 2.134, 132 rather. So that's our critical value. So we know that our critical value is 2.132. Okay, but as I said, because you're doing two-tail, you also have one on the left and one on the right. We just got the one on the right, so you can just reproduce them twice to get this answer. But again, if you don't do that, if you stop here, I'm okay with that for this class. Okay. All right, question on this? Degree of freedom. You got it. Okay. So remember that this degree of freedom keeps changing, right? So if I have one tail, let me put it down here. For one tail, for one tail test, the one that could say greater than or less than, your degree of, for one sample t-test, your degree of freedom is n-1 because there's only one sample, right? But if there are two samples, then your degree of freedom becomes n1 plus n2 minus 1, right? Okay, so that is the only thing that could change depending on the question you are getting. So if it's for two samples, we are going to use the one we have here because now you're accounting for the first sample, you're accounting for the second sample, then you have n1 minus 1. N1 plus N2 minus 1. All right, any other question on this one? Okay, so remember to do this in two parts. First of all, get your alpha, right? Next, get your degree of freedom. And then go ahead and use the table with the two information, right? Those are two you need, and then you pick up your table. Okay, so let's move to the next one very quickly. Number VI. Compute the test statistics, and this is about the most complex test statistics you can compute because that is the one that has the most numbers. So I'm using that to illustrate this. Okay. You have your formula sheet, and you'll be able to see that your test statistics for independent sample t-test is giving us independent. And you don't need to write all this, but I'm just using that to make it clear. So you see that that will be your sample mean 1 minus the sample mean 2 divided by the square root of the variance of group 1 all over n1 plus the variance of group 2 all over n2, right? So I would suggest in this question, just quickly get the piece of information you need, and the numbers will be very few, just 3 pieces as we have, so that I can calculate that very quickly. So let's see how quickly we can do that. So I'll look at the formula and then get all the piece of information that I need to be able to solve that problem. And before we plug in, so let's start with sample mean of group 1, and let me copy that table down here so it will be handy. Okay, good. Okay, we'll just keep it there. It's going to take some space, but we'll manage. So sample mean 1 will be 91 plus 93 plus 94 divided by 3, isn't it? So let's quickly do that. Should I have a calculator here? Okay, so we are dealing with 91. I'll use the keyboard. I think it will be quicker. Okay, 91 plus 93 plus 94, right? That gives me 279, right? 279, or is that 278? Then we're dividing that by 3, right? 278, and we're dividing that by 3. Okay. Okay, work with me here. So if there's a mistake, we'll quickly correct it. So this divided by 3 will give us 92.6667. So keep the 4 digits, right? It will save, remove issues of round of error. 92.6667. So I have 92.6667. Okay, that is mean of group 1, and let's do the mean of group 2 here. If you get a different answer, let me know. Okay. So for mean of group 2, we have 99 plus 96 plus 97. And then you're dividing this by 3, right? Let's use the calculator again. Do it on this side. So here we are dealing with 99 plus 96 plus 97. And we have 292. So we have 292. We are dividing this by 3. Divided by 3. That gives us 97.3333. So let's again keep up the 4 digits, right? 97.3333. Okay. So you've gotten the top parts of this. You've gotten these two. You know your n already, right? What you just need now is to the variance. So let's go ahead and get the variance. So let's do variance for group 1. And I want to do it horizontal. And maybe that could give you a different perspective, but it's the same thing if you also do it as a single, right? So we know that the formula here will be each data minus the mean for that group squared divided by n minus 1, right? This is the variance, isn't it? If I take the square root of this, I'll get the standard deviation. But since the formula actually has just the variance, I will just leave it as variance, okay? So how do we do this? Let me walk it horizontally. So first of all, this formula is asking you to simplify this and then sum them up, right? So let's do that. So let's simplify this for each data. The first data is 91, right? The mean for that group, I'm dealing with group 1 now. The mean is 92.6667. I'm going to square the results. Plus the second data is 93. The mean is 92.6667. We're going to square the results. Plus the last data there is 94. The mean is 92.6667. And we're going to square the results. And when we are done with all this, we divide with n minus 1, right? Which will be 3 minus 1. Okay. All right, so let's work this very quickly and maybe insert the values as we are working, so that way straightforward. So let's use the calculator again. So the first one is 91, right? Minus 92.6667. Okay, so that gives us -1 plus. So I think let's see if this square works. If this doesn't work, you can just multiply by 2, right? So let's square. Okay, so it gives us the answer when we click on square. So you have 2.7778. But this number here is 8 also. So let's say 2.779, right? 779. Okay. So we have 2. Okay. Okay, 2.7779. Okay, and then we go to the next one, plus the next number is 93. So you have 93 minus 92.6667. This is 0.000333. So we just click on the square, square it. You can just multiply the number by itself, right? And that is the square. So you have 0.1111, because this is 0 and that is 8, so we can just call it 1. So just keep the 4 digits, right? All true. 0.111 plus the last one is 94. 94 minus 92.6667. 6667. And then again, we square that. So we got 1.7777 because this is 8. So you have 1.47. Okay, so I'm done with that. Just divide by 2, isn't it? So let's see how we add that very quickly. I think I can use the keyboard now. So we have 2.7779 plus 0.1111 plus 1.7777, and that answer is 4 points. That divider, let's divide by 2. Okay, divide this by 2, and you get 2.3334. So we have 3434. So we have 2.3334. Okay. Questions? So we've gotten S1. We quickly do S2 the same way, just reproduce the same thing, right? The variance of group 2. We're looking for that, and again, it's the same thing, right? You're using N1 here. It's the same data minus the mean squared divided by N2 this time minus 1. So, you know, the sample could differ when you're doing independent sample t-test. N1 and N2 could have different values, right? But for simplicity, we are keeping them as the same value. So it's important we know which N we are tracking, we're dealing with, right? So we just track that. Let me demarcate this here. So let's solve this horizontally also, just the same way we did the other one. We start with the first data point, and we've lost view of our data here. Okay, I think we can see not very well. So let me copy this and bring it down again and see if that helps. Okay, so we just have 99, 96, and 97, right? I think we can remember that. So let me create 3 parentheses. We have 99 plus 96 plus 97. Is that correct? Yeah. Okay, so we just have all that. Let's put in the mean now and square them and sum them up. So the mean for this group, of course, is 97.3333, right? So we just keep subtracting that. So this will be 97.3333. This will be 97.3333. This will be minus 97.3333. Okay, so let's do all that and divide by n minus 3 minus 1. 3 minus 1. Okay, let's move this down a little bit. So again, let's use the calculator very quickly. We have 99 minus 97.3333. And we have this value and we square it. So here we have something similar to the other time. 2.7779 also exactly. Okay, as a coincidence. So we have 2.7779 plus, let's do the second one. We have 96 minus 97.3333. We have that value, we square it, we have, excuse me, 1.7777. Okay, so it's funny this where these numbers are recurring, but in different locations. Pure coincidence. So we look for the last one. The last one is 96. It's like just subtracting 1 from this, but let's still do it in full. So we have 96 minus 97.3333. That gives us -1. Are we doing the right thing? No. we've done number 2, right? And this is supposed to be 97. Okay, let's watch that carefully. I think we are doing, so we should be doing 97. So let's say 97 minus 97.3333. That should be negative 0 point something there, and we square that. So we have 0.1111, 0.1111. So look like the first answer, but their values are in different position. Okay. Let's go ahead and add this up and divide by 2. We should get the same thing, right? Because the values are exact. Yeah, so we don't really need to spend time working this. So if you look at this, we should have the same number, 2.3334. The value came out the same way. Okay, so we have those. We now have everything we need. You have your mean of group 1 here, you have your mean of group 2 there, you have your variance of group 1 here, and you have your variance of group 2 here. So let's just pick them up together, write them down, and then put them in the formula. Okay, so we know that T test for independent mean is equal to mean of group 1 minus mean of group 2, right? We're working on this formula right now. So mean of group 1 minus mean of group 2. Mean of group 1 is 92.6667. Mean of group 2 is 97.3333. So let's hope we can remember that. So we have 92.6667 minus 97.3333. Okay, divided by the square root of the variance of group 1. Variance of group 1 is 2.3334. So both of them happen to be the same thing. So we can just say 2.3334 divided by N1, which is 3, right? Plus 2.3334 divided by N2, which is 3. So notice a coincidence that we're having the same value, right? So we'll go ahead and simplify this. Let's do the numerator first. So for the numerator, we have 92.6667 minus 97.3333. This gives us negative 4.6666. So we have negative 4.6666 on the numerator. On the denominator, we work this carefully. Maybe we'll do it in parts to make it clear. So we have 2.3333 divided by 3. Okay, and that gives us this value. Okay, so let's say here we should have 0.7778. Yeah, so we should have, because they just happen to be the same, so we should have 0.7778 plus another 0.7778. Right, this is all we have. So let's go further. Negative 4.6666 divided by the sum of those and their square root, right? So we have 0.7778 plus another 0.7778. This gives us this, and we're going to take the square root. So I don't know if the square root works the same way, but let's write this down first and then see. So this gives us the square root of 1.5556. So we're looking at the square root of 1.5556. Okay, so this will be minus 4.6666. You don't have to write every step, I mean, as detailed as I'm doing it, but I'm just, kind of using that to ensure that we don't make mistake. Okay, so we need to take the square root of this. So that will be 1.2472. So 1.2472. And then we divide those two of us. 1.2472. So now we divide, I could just ignore the negative number, just divide the whole number, but remember to put the negative number back, right? 4.6666 divided by 1.2472. Okay, 1.2472. This gives us 3.7417. So we have 3, but we remember our negative number, right? We don't want to forget that, so let's write it down first. This gives us negative 3.7417. Let's be sure that is what we have. Negative 3.7417, okay. So that is your test statistics, right? I hope it matches what we have earlier in the answer key. So yeah, that is what we have here, right? So work with 4 digits and you'll be able to match the answer directly, but I'll be going into credits. Make sure you have all the credits that you deserve, okay? Okay, so this is the most complex you could have. It could be one sample, it could be, something paired sample, right? Each of them have different working, but I would say to get all the variation possible, go to quiz 2, solution to quiz 2. Move this away. You have a question? Yeah, go ahead, please. Right. Uh, 2.3334. Oh, so you see the square root is covering both the numerator and denominator, right? You mean, why didn't I square that? Oh, raised to the power of 2. Oh, okay. So, and that is the source of likely mistake, right? So we worked the variance, right? We solved and we got the variance, and the formula here has the variance, right? So it's already squared, and so the answer we got is already the squared form, right? So if you want to get standard deviation, then you take the square root of that. But that will be redundant, right? Because we know we eventually will square it, so there's no need to take the square root, right? Okay. Okay, so that is a good observation. That is a point where mistake can easily come as well. So if you know the formula is already here, then just use the variance the way it is. But if you decide to do the standard deviation here, which means you take the square root of your answer here, then you remember that you need to square it back when you are putting it back into the formula. Okay. All right, any other question on this one? Okay, so I was saying, you have this question, this is the sample question, right? So to get the different variation possible, so you might get this one, somebody else might get something else. To get those different variation, go to quiz 2 and review quiz 2, right? Quiz 2 covered the 3 possible variation you could have under assessment, isn't it? So look at these solutions. They cover the 3 possible variation you could have, and you will be okay with that. But this is like the one that has the larger formula, sort of. Okay. But they will all have the similar level of difficulty, so it's not going to be a lot of challenge. Okay, so this also has the advantage that we can pick up all these variables, all this data that we derived here to answer the subsequent questions. So let's go ahead and do that very quickly. So we have our test statistics. So the next thing is to calculate the p-value. And we can just confirm that, but writing it down here, the way we look for it on Excel, remember, using Excel, we do t.dist. And so this is where it's important to remember that you're doing two-tail, right? So you must use t.dist.two-tail divided by, the first thing you have will be your test statistics. So I will call it just test stats. And then you have your degree of freedom, right? So take note that we're doing 2 samples, that the degree of freedom here is n1 plus n2 minus 2, right? Which was 4 for us because this was 3 plus 3, right? Okay, so we've already got our test stats and we've got our degree of freedom. We just go in and insert them. So you have t dot dist dot 2t all over test statistics is you use the positive one, right? 3.7417, comma degree of freedom of 4. So we just put in this, excuse me. Sorry about that. We'll just put this in a cell. So let's open a cell very quickly. Let me see if we can view the two screens at once so we can view the values. Okay, so this is close enough. So we type equal to t dot dist, and we're picking two tail. Let me double click on that, and then we'll put in our test statistics, which is 3.7417. Excuse me, comma degree of freedom of 4, close the parenthesis, and you have that value. So we have 0.020091, 0.020091. Okay, so you can round off to 4 digits, which would be 0.02009. Okay, so again, maintain 4 digits. So your answer will track. Oh, okay, so I actually have 3. Okay, so I have a little bit more than 4 digits. Okay. Yeah, if you have more than 4 digits, that is better actually, right? It won't be penalized. So I have that if I round up to 4 digits, 4 decimal places. Okay. Any question on this one? Okay, once I get my degree of freedom, then we'll go ahead. It says, based on the all your answers provided so far, what would the result of hypothesis test suggest? So hint here, you are just supposed to say reject or fail to reject, right? Okay. Any idea? Are we going to be rejecting here or failing to reject? Remember how we make that decision? There's actually one I didn't teach in class, which is using the critical value to make that decision. But let's focus on the one we worked in class. So let me do that with green, right? So you know that if p-value is greater than alpha, right, then you fail to reject. Right? But if p-value is less than alpha, then you reject. So in this case, in this question, we know that we have the second scenario. Yeah, we have the second scenario, right? So let's use red to write that. We know here that our p-value, which is equal to 0.020001, is actually less than alpha, which is equal to 0.1, right? So because of that, we'll reject. So our answer will be this one. Questions? Yes. Oh, okay. Yeah, of course. So the video will be uploaded, and then you want me to upload this paper also, right? Okay. Yeah, I'll do that. So yeah, I'll just have to remember to save it at the end of today's class so that it doesn't get lost. But I'll do that. So reject. So we reject the null hypothesis. We'll go to the next question. It says, provide the reason for your answer in A above. And we rejected, we just explained the reason here. this will be sufficient for us in this class, right? So we say we rejected because we rejected the null hypothesis because p-value was less than alpha. And you can say significant level, right? So whichever one. Okay. And then you state your conclusion. So again, I'll be flexible about the statement of conclusion, but the key thing is that write it in the context of the question you have, right? So we write it in that context. We could say there is enough evidence in the data to suggest, remember you rejected the null hypothesis. The null hypothesis was saying before and after are equal. Alternative is saying they differ. So when you rejected the null, which says they're equal, it means you're supporting that they differ, right? So there is enough evidence to suggest that the mean blood sugar level before exercise differs from mean blood sugar level after exercise. And this you can just write in your own words, right? But capture the key things and that'll be fine. Okay. Any questions so far? Okay, so this part says, assume for the next section, right? One of the data sets is assigned to you. So, but we're just saying for this class, assume that the one that was assigned to you was before, right? So you just look at the values for before, you're using that to answer the subsequent question. So, so this is where I'm actually testing understanding of concepts. You know, because if you understand concepts, then most of these questions you hardly need to do any work. It's kind of going back to what you already did, picking up the right answer and putting them in the right place, right? You know, so it will look like the question is many, but if you understand the concepts, so this set of questions is just testing whether you do actually understand that concept. So let's look at all this. What is the appropriate critical value? So it doesn't matter that you're using only one sample to do the critical value now. The critical value will always be the same thing because the critical value does not depend on the sample. It doesn't depend on it. It doesn't have anything to do with sample. The critical value depends only on your alpha. Remember the formula for critical value is just T alpha over 2. So this says that the same thing you did before. So you don't really need to repeat that exercise again. Just pick up that number and put over here. That is the answer, right? Because critical value is critical value everywhere. It has nothing to do with sample size. It just has to do with alpha. Okay. Then over here, I say, what is the appropriate confidence level? The same thing we did before, right? The critical value, the confidence level has nothing to do with the sample. It's just a decision you make before you actually start doing your research, right? So you see that the confidence level is still the same thing as 1 minus alpha, right? And if you solve that, you get the same 90% as we got before. What is the point estimate? So of the population mean. So let me put this in green here. Just remember, this question is simply asking you for the sample mean, right? Point estimate. It's just another fancy way of saying what is the sample mean. Okay. Again, we've already worked the sample mean. Just pick up that answer and put here. You're not doing anything new, right? You know. So the next one says compute the standard deviation. We've already partially done this. We did the variance. So we just go pick up that number, take the square root, and that is our standard deviation. So we'll pick up the number here. We have standard deviation for group 1 is 2.3334. So let's come over here. So what we're just doing will be, I think we should do it in green, is just standard deviation is the square root of variance, right? So, and that is the square root of 2.3334. If you take the square root of that value, I bet you'll get this, right? Okay, so let's do it very quickly. So we are looking at 2.3334, and we're taking the square root, and that is 1.5275. Okay, yeah. Then the other one says calculate the standard error. Then this is where something new comes in, but it's not something new in a big way, right? Because you already have all the parts you need. The standard error, you just need to remember the formula. And if you don't remember, I can give it to you during this. So standard error is simply standard deviation divided by square root of n, right? So we already got the standard deviation as 1.5272. We are dividing that by square root of n. We know n is 3. So we do this. 1.5272 divided by square root of 3. So let's look at square root of 3 first. So square root of 3 is 1.7321. So I'm doing 1.5272 divided by 1.7321. Let's confirm that as well. 1.7321. Okay. So I just divide those two, and that's my standard error. 1.5272 divided by 1.7321, and I have 0.8819. Okay, so this differs slightly, but it's okay. 0.8817 is what we have here. 0.8817. So if you get up to 2 decimal places, the rest will be ignored. Okay. So you have that question on that. Speed up a little bit. So you have the margin of error here. So these are all concept questions, right? If you remember the concepts, you will be able to just pick up the answer. So margin of error, if you remember, is just your critical value times standard error. That is the margin of error, right? So you know your critical value is T alpha over 2 times, you know your standard error is standard deviation divided by square root of n. And you already have all these values, right? So let's go pick them up and put there. Critical value, let's go all the way to the top. Our critical value is 2.132. Okay, so this will be equal to 2.132 times, then we pick up the standard error, which we just solved, 0.8817. Let's use our own value, okay? It will make the answer different a little bit. 0.8817. So we multiply those two. 2.132 times 0.8817. That gives us 1.87. Okay, so let's be sure this value is, the critical value is correct, right? The critical value is 2.132. Okay, so we got 0.8817. We got 1.8797, right? 1.8798. Okay, so I have here 1.879. 1.8798. Okay, so it differs a little, but it runs up to that. So assuming I use the standard error here, assuming I use this one, 0.8819, so I would have had 2.132 times 0.8819, that would have given me the number I have here. So that error is coming from the fact that we already had a difference in answer here, so it carries that along. And, but again, if you notice on quiz 1, you were not penalized twice. Like, I am following what you are doing and I am grading it that way, right? Okay, so we are not going to bother about that. But of course, when your answer differs from second decimal place, it could be so clear that you're having a round-off error. Okay, so maybe I think this one was done with system that use all the numbers instead of some of the numbers, instead of 4-digit that we're using. Okay. So the next one, say, what is the confidence level interval? The confidence interval, again, this is a concept question as well. The confidence interval, remember, is the sample mean minus margin of error, right, on the lower side, and then the sample mean plus margin of error on the upper side, right? So let's put in those values. The sample mean for the part we are solving is we already did 92.6667, and we just did the margin of error, so we can pick that up. So you have 92.6667 plus 1.8798, excuse me. So the answer will differ a little bit from this, just as we already know why. So here we also have 92.6667 plus 1.8798. Okay, so if we do that, let's do a calculator here. Did I close that? Like I did. Okay, so I have 92.6667 minus 1.8798, and this gives me 90.7869. Okay, and then the upper one will be addition of that. So 92.6667, this time plus 1.8798. This gives me 94.5465.
That's the median of one sample group and the median of another sample group.
You mean the mean, right? Yeah. So it's the mean of only one sample. So remember, all the question you're answering, you're doing it with this instruction, right? And this instruction says just use the sample data before. So all you are doing is the mean that you got from. Sorry, I think something is coming up. All you are doing is the mean you got from this first group. Yeah, so you're only using this one. Because and then this is where I randomize it. So maybe for somebody by your side, the person might be using this second data set. Yeah. Okay. And yes, go ahead. Yeah, so that would be randomized. So it could be dependent, it could be independent, right? But the way it happened in quiz 1, I mean in quiz 2, the storyline will be the same thing. Like if I want to make this dependent t-test, I will just tell you it's the same group of people that took it after, right? So if I give you this story and say it's the same group of people that took before and after, then of course it's dependent. But if the story says different two group of people, then you're doing independent. Yeah, so for purposes of balancing the class, some will get dependent, some will get independent. Okay, but the number of questions you have will be equally weighted. We know that independent has more sub-questions. So if you're solving independent, you might get a little more questions. I mean, if you're solving dependent, you might get a little more questions because people who are doing independent might have a little more work to work. So I'm going to do them, they are weighted equally, right? Okay. So it's going to be that. So I would say prepare for the two, be comfortable with either one. And the critical thing is actually making that decision. Are you doing dependent or independent? Once you make that decision correct, every other thing follows, right? And have your formulas. If you forget anyone, let me know and we can give it to you. Okay, so that is really that about that. Let's speed up a little bit. Let's go to see if we can at least do one question on these two parts because they're essentially the same, really, right? These other two. So let's start with the first one here, number 4. Okay. This first question is redundant, so I would likely just remove it there. It's not necessary. Yeah, but I could just leave it for you to get some free point. So here it says, on a planet far, far away, the IQ of species is distributed with the mean of, we're paying attention to these values, right? Mean of 113 and standard deviation of 17. So in the first, this normal distribution is symbolic. In the first part, you're supposed to have your mean, 113. And in the second part, you're supposed to have your standard deviation. So this is written as X is distributed as, normally distributed as mean, comma, standard deviation. So this is this symbolic notation. Okay, so you put your this and this. So if you do this course beyond this place, you see the need for having that. Okay, so the next one will be find the probability that randomly selected person IQ is over 96. Okay, so I want to, okay, this is a picture. I can't really shift it. That's unfortunate. Okay, so I want to draw a little bit, right? So we are looking at, this is your distribution, and this question is saying, the mean is 113. And you have somebody here, 96. The question is saying, what is this area? That's what we're asking essentially. What's the probability that the IQ is over 96? So you pick your 96 above 96. So what you need to do is to find the Z value that is equivalent to this 96. Once you get that Z value, you use your table to find the rest. So let's do it quickly here. So the Z value that is equivalent to the point where we have 96 will be, okay, so let's try the Z value formula first. The Z formula says Xi, the data minus the mean, divided by standard deviation, right? So here we have the data, which is 96, minus the mean. We know the mean here is 113, divided by standard deviation. We know standard deviation is 70. So let's quickly do it. 96 minus 113 is equal to 7. Okay, negative 17 divided by 17 will give us positive 1. Will give us negative 1, of course. So we have negative 1 as our Z value. So we just go to the table and find out the area on negative 1, right? So just go to the Z value, but pay attention that the table, normal table, the Z table, you see this sample shaded area here. It's simply telling you that whatever area you find is from the left tail. Why is my right? Okay. Whatever area you find on this table is on the left tail. Okay, so, but in this question, you remember we asked above. So once you get what is in the left tail, you have to subtract to get the above, right? So let's go for negative 1 Z value. We come over here, we have negative 1 on this spot, and we're picking that value there, the first one, because it didn't have any other thing, just negative 1. So this value is what we have, but remember you have to subtract 1 from that. So this is 0.1587. So it's like saying this area is 0.1587. So the question is, what is this red area? That's what you're looking for. So this is why you have to do the answer to that question. This question would then be, let me go back to red. The answer to this question would then be 1 minus 0.1587. Okay, so if we subtract that, let's see that we get that value. 1 minus 0.1587. So we have 1 minus 0.1587. Okay, so you have 0.8413, which is the answer you have, right? So you have 0.8413. Okay, so you have that. Okay, So if the question has said below 96, then right away, this is your final answer. It has said below 96, right? But it says above 96, so we know we have to solve that. So let's look at the next one very quickly. It says, a school offers services for people 2% who has IQs 2%, below 2%, right? At the bottom 2%. What is the highest IQ? So this time around, so in this question, it gave us IQ and want us to find the probability. So it's like it gave you the number here. I want you to find the area. But in this question, in number C, it's giving us the area and want us to find the number, right? So let's look at it here. Think for clarity, let me start using different color for different solutions. So for question C, we are using green. Okay. So again, if we sketch this, it will be something like this. The bottom 2% is here. So the question is just asking you, what is the number here? What is the IQ that is at that spot, right? So it's the opposite way. So I just go to the table, you know, from the table we find area. So I just go to the table and look for the area that is equal to 2%. And we know that 2% is the same thing as 0.02, isn't it? So I'll just go to the table and look for 0.02 and find out the Z value that is equivalent to that. So going back to the table, look for 0.02. This is 0.02 here, but it's still big. So let's go down until we get the closest. So maybe the closest is here, right? 0.022 or something like that. Is that right? Yeah, 0.022. This is the closest. This one is smaller. I'm going from the negative side, so I want to remain on this side of the table. So you have this, and you've gotten that from -2. That is your Z value. That's equivalent to that. And it's on top of 5. So I have -2.05, right? So let's go back there quickly. So I have that my Z value here is equal to -2.05. Okay. So, but the Z value is a Z value from the table. The question wants you to get the IQ score. So you just use the formula for Z value to just complete it. So if you remember the way we normally write this in a more quickly way, so you could say, okay, so your Z is equal to data minus the mean divided by standard deviation, right? Sample or whatever. So you are looking for this essentially. So if you do your algebra, then that value will be equal to the standard deviation times, Z value times standard deviation, right? Plus the mean. Okay, so Z value here is -2.05 times the standard deviation, we know to be 17. And then we're going to add the mean, which is 113. Okay, so just use calculator. So you have, and I will just use I'll just use, okay, I can actually put the negative sign here. So let's say negative, hope that works, 2, okay, maybe you put it at the end. Let's see, 2.05 negative, right? And I'm multiplying this by 17. I have that value, right? And I'm going to add 113 to it. I have that value. So I have 78.15. So it differs slightly from what we have over here, right? So I have 78.15, so 78.15. I answered that question, right? So let's see if we can finish out this before that. And what I'm going to do, so, okay, let me finish this and then I'll talk about that. Yes. Mm-hmm. Mm-hmm. No, so I know that this one in the system, they are using like calculator or maybe computer to do it. So they are getting it's like I'm using all the numbers to do my computation. So I'm getting more exact things. So of course, I will know that this happens here. And just as we did in the homework, you won't get counted for that, right? Yeah. Not different round-off error per se. I mean, it's still a round-off error, right? But this is much more flexible, right, than the other ones, right? But of course, you know, if you get something like 75, right, 79, if you become way off, then something is wrong. But if you become way off that way, I'm looking at your work, I'm going to be able to follow you and get to where you get, right? Yeah. So that will have a much more flexibility than the other one. Okay. So we have about 5 minutes left, but let's see if we can solve one of these and then, okay, so let me see what to do. Let's just continue and see how much we can do out of that. So the first one says, what is Q1? And this question's question D will just be repetition of question C. You know, just something you're doing because all of these are areas. So Q1 is 25 percentile, isn't it? Q3 is 75th percentile, right? And then you just subtract the two answers. So this question is simply asking you to find if this area was 2% here. If the area was 25%, what would be the answer? You are repeating the same thing we just did. If the area was 75%, what would be the answer? You're repeating the same thing. Okay, but let's see, at least we can do Q1. I'm going to use, let's go back to red to make it different. So this question is saying, if Q1 is 25%, the lower 25%, the question is, what is the value here? What is the IQ at this spot? So again, I want to get the Z value and then use this formula as we did here to get it to the actual value. So, okay, the Z value again here, we'll be looking for 25% in the table, and 25% is equivalent to 0.25, right? So let me go to the table and get 0.25. Okay, so over here is 0.24, 0.23, so it's changing 0.25 here, 0.25 here, 0.24. So I'm going to stay with this one. So this is under negative 0.6 and 7. So it means here I should have negative, your Z value is negative 0.67. Okay. So just as before, plug in and you get the same answer. So your data value here, your IQ here, will be negative 0.67 times 17 plus 113. Okay. So let's simplify this very quickly. So negative 0.67. Put in negative sign there, times 17 plus 113 equals to 124. Are we getting the second answer? All right. Say that again. It's positive instead of negative. Okay, so I think we didn't start in negative. So have 0.67, thank you. We have a negative number there. We're multiplying this by 17, right? So the result should be negative. Okay, plus 113. Yes. So we have that 101.61. 101.61. Okay, so it's still close enough. What I did now is the same exact thing you're going to do for this one, right? And let me use a different color for that. So assuming we pick blue for that, I know we don't have enough time to finish that, but assuming we pick blue for that, the same thing, you are looking at a shape like this, and this is 75%, right? So, and you're looking for the value here. So again, just go to the table and pick up the Z value that is equivalent to 0.75. Use the same formula to convert it and you get this value, right? And then once you get it, interquartile range will be whatever you have here, Q3 minus Q1, and then you have this answer. Okay. All right, so don't bother about, I'm going to take that off, right? So this question is something as the one we just did. Question 5 is exactly the same thing as question 4, but I'm going to take it off because it's redundant. Only it is actually bringing in something new. It's bringing in central limit theorem right here. Okay, so but just take that off the assessment. I'm going to remove that. Okay, so if you look at section, this question is in section 2. If you look at section 2, so if you look at section 2 here, you have 3 concepts: binomial distribution, normal distribution, and then central limit theorem. So that second question is coming from this one. So what I'm going to do for the final, I'm just going to remove central limit theorem. Okay, and I will send you an email explaining that. So just focus on unit 4 and 5, forget unit 6. Okay. All right, so I hope this is helpful. I know this is a lot of pieces all over the place. And if you learn this very well, of course, and you want to retake quiz 2, it's essentially the same thing that you're going to be retaking, right? So retake quiz 2 if you want to. There's no harm in doing that, right? Because if your quiz 2, if the one you retake is smaller than the one you got before, we still use the bigger one of the 2, right? And if you retake it and it happens to be bigger, of course, we use it. So that is advantage for you. So there's nothing to lose taking it. And then this knowledge we also transfer to your final, right? Because it's also the same final you're studying for. Right? So that would be that. Sorry, we took 2 minutes more. But any concerns?
How are the retaking this to actually work?
I think we can do it remotely, except if I have many people request. If it's just 2 or 3 people, like I can send it out. I can use Zoom to monitor your outlook. Let me think through that and send the instruction out today or maybe tomorrow.
Can you upload this?
Yes, so let me remember to save it and upload it. Yeah. Yes, please. Yeah. Okay. So just quickly write me. Okay, I think the video is still going.
You said for the quiz if we take in with the answer, right?
Yeah, so I think, yeah, it's perfect. I think